Hey, hello there, welcome to CS School channel. In this video we are going to look at peak element problem. This problem is asked a lot of time in different coding interviews. The link of this problem is in the description of this video, so do check it out and try to solve it on your own. If you can't solve it, come back to this video. Now let's look at the problem statement which is given on the screen. Given and zero index integer array nums, find the peak element and return its index. Okay, now what's the peak element? A peak element is an element that is strictly greater than its neighbors. Okay, so any element which is greater than its neighbor is a peak element. If array contain multiple peaks, then return the index of any of the peak. So there is no constraint about returning the index of the peak. Okay, so you can return any peak of the array. Okay, so here is the input array nums with the value 1 2 3 1. Now which is the peak element? 1, is it a peak element? So on the left there is no element, right? But on the right there is an element, and 1 is actually smaller than this 2, right? So it is not a peak element. Now consider this 2 is greater than 1, okay, but this 2 is smaller than 3. Okay, what is the condition of peak element? It should be greater than the neighboring elements. Okay, so 2 is actually lesser than 3, so it's not a peak element. Now consider this 3 is greater than 2, right? Also 3 is greater than 1, right? So actually 3 is the peak element, and that's what we have written in the output 2. Okay, the index of 3. Okay, then we move on to 1. Is 1 a peak element? Actually 1 is smaller than 3, right? So it's not a peak element. Okay, now let's move on to the next input, which is this array 25 5 10 20 22 26. Now consider 25. Okay, on the left there is no element. If you consider on right, there is 5. Okay, so 25 is actually greater than 5, right? So we can consider 25 as a peak element and return its index 0. Okay, let's move on to 5. Is 5 greater than 25? No, so it's not a peak element. Consider 10. 10 is actually greater than 5, but 10 is smaller than 20, right? So it's not a peak element. Now consider 20. 20 is greater than 10, but 20 is not greater than 22, right? So it's not a peak element as well. Consider this 22. 22 is greater than 20, but it's smaller than 26, so it's not peak element either. Now consider this 26. Is it greater than 22? Yes, it's greater than 22, and there is no element on the right hand side, so 26 can be considered as a peak element, and we can return its index as an output. Okay, so hope you are clear with sample inputs and outputs. Now let's look at the first approach of solving this problem. Now let's look at the first approach, which is linear search approach for solving this problem. Okay, so in this approach we will iterate over all the elements in the array. Initially we will start with the first element, this 25. What we will do, we will compare this element 25 with the left and the right element. Okay, as the left element doesn't exist, we will compare it with the right. Is 25 greater than 5? Yes, it is, right? So in this case we will return the index of this 25, which is 0. Okay, so suppose 25 would have not been the element, we would have moved the 5. Then we would have checked, is 5 greater than 25 and 5 greater than 10. This is not the case. We would have moved to the next element, so on and so forth, right? So we would have compared each element with its neighbors. Okay, and we would have returned the index if the criteria has been matched. Okay, so what is the time complexity of this approach? Well, as we are running one for loop over all the elements in the array, and at max we can compare to the n number of elements, the time complexity is O of n, right? And what's the space complexity? As we are not using any extra space, the space complexity becomes O of 1. Okay, so pretty simple linear approach. Now let's look at how we can find the efficient solution for solving this problem. So to solve this problem efficiently, we can actually use binary search. Okay, how we can use binary search? Let's just see that. So suppose you have calculated the mid. The mid will be 0 plus the length of the array 0 1 2 3 4 5 5 divided by 2, which will give us 2. Okay, so second element is at the mid, so 0 1 2. Okay, so this 10 is at the mid. Okay, now we check whether 10 is peak element or not. So 10 is greater than 5, but 10 is smaller than 20, right? So 10 is not a peak element. Now in the binary search, what we do, we either discard the right hand side and move to the left, or we discard the left hand side and move to the right, right? So we need to decide where to move next. Okay, now consider this. 5 is already smaller than 10, okay, and 20 is greater than 10, right? So there would be a side which have an element greater than this element, right? Because it's not a peak element. Okay, now tell me, on which half do you think there is a higher chance of finding a peak element? The side where the element is smaller or the side where the element is greater? Absolutely the side where the element is greater than the current element. Why that's the case? Because see, if we move to the 5 side, there can be a chance that the next element can be a smaller than 5, right? In this case, there won't be any peak element because 5 would be lesser than 10 and it would be greater than 3, but 3 is again lesser than 5, right? So peak element won't exist in this case. But here there can always be a case where the peak element exists. Okay, now consider we have 20 here, right? Next element either can be greater or smaller. In this case it is greater. Okay, so if the element would have been smaller, something like 19, then this is the peak element, right? Because 20 is greater than 19 and 20 is greater than 10 already, right? But here it's not the case. We have 22. So after 22 also there can be two cases. Either the next element could be smaller, something like let's say 21, or it could be greater, 26. Now if the element would have been 21, then 22 would have been the peak element, right? Because 22 would have been greater than 20 and it is greater than 21. Okay, similarly there is case with 26. Okay, as 26 is the last element, it can be either greater than or smaller than the previous element, and in this case it is greater. So there is always a chance we can find a peak element on the element side which is greater than the current element. Okay, so that's why we will move to this side. Okay, and we will start doing binary search again. Okay, so hope you are clear with the intuition of solving this problem. Now let's look at the step-by-step execution of this algorithm. Now let's run through the approach that we have just discussed step by step. Okay, so initially we will start with low is equal to 0, high is equal to 5, and then we will calculate the mid. So the mid will be 0 plus 5 divided by 2, which gives us 2. Okay, so mid will be initially here. Now we will compare this 10 with 5 and 20. Is it greater than 5? Yes. Is it greater than 20? No, right? In this case, what we will do, we will move our low to the mid plus 1. Okay, so we will kind of discard this entire half of the array. So now our low becomes mid, which is 2 plus 1, which is equal to 3. Okay, so our low is here now, low. This is our high. And now again we will calculate the mid. So let me just do that. So our mid becomes 3 plus 5 divided by 2, which gives us 8 divided by 4, which is equal to 4. Okay, so our mid is now here. Okay, then we will compare this mid with low, this mid with its previous element 20. Is it greater than 20? Yes. Is it greater than 26? No, right? Now we will check which side is greater. Okay, so 20 is not greater than 22, but 26 is greater than 22, right? Then we will move the low to mid plus 1. Okay, so our low becomes now 4 plus 1, which is equal to 5. Okay, so our low and high will point to the same element. Okay, now let's calculate mid again. So our mid becomes low plus high divided by 2, which gives us 5. Okay, so our mid will point to the same element. Now we will check whether this element is greater than its adjacent element. Well, it is greater than 22 and there is no element existing in this side. We will return the index of this element. So we are returning 5 as our final answer. Okay, so hope you are clear with this approach. Now what is the time complexity of this approach? As we are using the binary search approach with just little bit of modification, the time complexity will be similar to binary search, which is O of log n. Okay, and what is the space complexity? As we are not using any extra space, the space complexity becomes O of. Okay, so hope we are clear with this approach. Now let's look at the C++ implementation of the same. So here is the C++ solution for solving this problem. Okay, so we need to complete this find peak element function, which accepts vector of integer nums as an input, and it expects the index of the element as an output. Okay, as in the binary search, we are initializing two variables, low and high. Low will point to 0, high will point to the array size -1. Okay, if the array contains only one element, that means that is only the peak element, right? So in this case, we are returning the index of the first element. Okay, after that we are having a while low, with low is less than equal to high. We are calculating the mid. Now we are considering two separate cases for the first and the last element, as we need to handle those cases separately, right? So if mid is equal to 0, we are comparing our current element with the element next to it, mid plus 1. Okay, if the current element is greater than mid plus 1, that means we need to return the mid. In all other cases, we need to return mid plus 1. Okay, this condition will only hit if you have only one or two elements remaining. Okay, in all other cases this condition will not hit. Now in the else if condition, we are checking if mid is equal to the last element. If that's the case, we are checking whether the last element is greater than the second last element. If that's the case, we are returning the index. Otherwise we are returning the second last element's index. Okay, again, this condition will only be there if we have checked an entire array and we are remaining with only two elements. Okay, in all other cases, we are checking whether the mid is greater than mid -1 and mid is greater than mid plus 1. If that's the case, we are returning the mid. In the case where mid is lesser than mid -1, we are moving high to mid -1, and in the other case, we are moving low to mid plus 1. Okay, if the element is not found, we are returning -1. Okay, now for running this function, we have written this main function. We have defined the vector of integers nums, and we are calling the find peak element function, and whatever the output that is given by the function, we are printing it onto the screen. Okay, so hope you are clear with the C++ solution for solving this problem. Now let's run this code. So we get 5, which is the index of this 26 element. Okay, so hope you are clear with the problem and its solution. If you have any doubt, do ask me in the comment section. I'll be more than happy to help you. We will be making more such videos in the future, so do subscribe to our channel to receive updates if you upload any video. Okay, thanks for watching and stay tuned for further updates.